Now let's look at this integral. We're supposed to evaluate this integral, but we do not know whether this is a proper integral or an improper integral. So let's look at some weird behaviors of this function. Okay, now we know that sine inverse of 1 is pi over 2, and due to continuity of the sine inverse function, we can at least say that limit as x tends to 1 from the negative side, because we cannot take values outside of this interval to define the sine inverse function. Sine inverse of x is pi over 2. So basically that means limit x tends to 1 from minus tan of sine inverse x is equivalent to limit x tends to pi by 2 from minus, because sine inverse x ranges between these two values, and if the limit is pi over 2, it approaches the value pi over 2 from the negative side. Okay, so let me just write theta over here. Tan inverse of tangent of theta, this is infinity, so we have an improper integral because there is an infinite discontinuity at the point 1. At the other points, the given function is continuous. So we have an improper integral of the form a to b fx dx, where the function is continuous on this interval and has an infinite discontinuity at x equal to b. So in order to evaluate this integral, we're going to need this limit r tends to 1 from minus 0 to r tan of sine inverse x dx. Okay, now if this limit exists, we're going to say that the given integral is convergent and the value of this integral is equal to the limit which we just evaluated. If this limit does not exist, and by does not exist I mean to include, by saying that the limit does not exist, I mean that the limits are supposed to be real numbers. We cannot even include these cases. Okay, we cannot include these cases. Now let's see. To evaluate this integral, let me use the substitution theta equals sine inverse x, which would mean x equals sine theta, and for 0 we get sine inverse 0, which is equal to 0, and for r we get sine inverse r. So this will be equal to limit r tends to 1 from minus integral from 0 to sine inverse r, and I've used theta over here, so I'm going to use the variable d theta. And to change the variable from x to theta, I must use the substitution factor d theta over dx. Now if you look at the function theta equals sine inverse x carefully, this is an invertible function. This is an invertible function. So for invertible functions, we're going to get something like this, and this means dx by d theta is equal to d theta over dx at points where it's non-zero. So limit r tends to something like this: sine inverse r tan theta And I'm just going to replace the derivative with this expression, something like this. Now dx by d theta, this is equal to cos theta, limit r tends to 1 from minus 0 to sine inverse r. We already have a tan theta over here, and dx by d theta, dx by d theta means dx by d theta means dx by d theta means d by d theta of sine theta, which is equal to cos theta. So I'm going to introduce the factor cos theta over here, d theta. So this will be equal to limit r tends to 1 from minus 0 to sine inverse of r tan theta. Oh, sorry. Let me use sine theta over cos theta times cos theta d theta, where I've used tan theta equals sine theta over cos theta. Alright, now we can cancel out these two things, cos theta, to get limit r tends to 1 from minus 0 to sine inverse of r sine theta d theta. Okay, this is what we're going to get. Now we know integral of sine theta d theta equals minus cosine theta plus c. So I'm going to do something like this, limit r tends to 1 from minus minus cosine theta 0 to sine inverse r. Alright, this is equal to limit r tends to 1 from minus, let me use sine inverse r. Let me use sine inverse r. I'm going to get sine inverse of r, something like this, negative, and this negative makes things positive, so cosine of 0. This is what we are supposed to get. Now this is equal to, furthermore, this will be equal to limit r tends to 1 from minus, this is equal to 1, minus cosine of sine inverse r. Alright. Now let me see. Limit r tends to 1 from minus sine inverse r. This is equal to pi by 2. And since cosine function is continuous, we can write limit r tends to 1 from minus cosine of sine inverse r as cosine of limit r tends to 1 from minus sine inverse r. This will mean this is equal to cos pi by 2, which is equal to 0. So what I did just now is that I've just shown limit as r tends to 1 from minus the limit of this function as r tends to 1 from minus is 0. So this basically reduces to the value 1. So this basically means integral from 0 to 1 tan sine inverse x dx is convergent, first of all, because this limit is finite, convergent, and what else do we have? And 0 to 1 tan inverse of, oh no, tan of sine inverse of x dx is equal to 1. Okay, that's how I would like to do it. All right, thank you very much.